Hey there, in this video we're going to talk about section 1.6 complex numbers. So this is going to be an introduction. I'm going to record a few videos on this section. So the first thing is, what is a complex number? So a complex number is a number of the form a plus bi, where a and b are real numbers and I is equal to the square root of -1. So A is considered the real part and BI is the imaginary part. So this we say that's the real part and BI is the imaginary portion. So essentially, if you think back to when we talked about the real numbers, in the real numbers you have the natural numbers, which are the counting numbers, the smaller set. Then we have the whole numbers when you add in 0. Then you had the integers, you add in the negative whole numbers, then the rational numbers. The real numbers is everything, the rational numbers and the irrational numbers. Now the complex numbers are essentially a much larger set because every real number can be written as a complex number. So any real number can be written as a complex. So every real number, I'm just going to say, is complex. For example, the number 2, right, can be written as 2 plus 0i. Then number pi, this is an irrational number, can be written as pi plus 0i, and so on. By a rational number, real number, 2/3 is 2/3 plus 0i. Essentially, the imaginary part can be written with a coefficient of 0. So all real numbers are complex numbers, but it doesn't go the other way around. Complex numbers are not necessarily real numbers. If I have 2 plus 3i, right, this is not a real number because there's the real part, but I have an imaginary part. So with I being the square root of -1, we can define other things. So what is I squared? Well, I squared then is the square root of -1 quantity squared. Just replace I with the square root of -1 and you get -1. So I squared is equal to the real number -1. Then what about I cubed? Well, I cubed, I can write it as I squared times I, deconstructing using the rules of exponents. I to the first, right? So then when you multiply same bases, you add exponents. So 2 plus 1 is 3. And we can say then, I already know I squared is -1. I get -1 times I, so it's -I. And then what about I to the fourth? I to the fourth, we can say this is I squared times I squared. I squared is -1, so I can say -1 times -1, which gives us +1. So from these, we can rewrite them as the square root of -1 is I, then I squared is -1, I cubed is -I, and I to the fourth is +1. And these are helpful for when we start doing operations with complex numbers in terms of simplifying. So for example, I'm going to have us simplify, let's say I want you to simplify I to the 13th power. So what is that going to be? So we don't want to necessarily go all the way down the line here. We want to be able to use these as our guide and to help us. So I'm going to, kind of like I did here with I cubed, we're going to use the properties of exponents in the backwards manner. It's like kind of, what did I call it? Deconstructing. So I can say this is I to the 12 times I, right? I to the 12 times I to the first. 12 plus 1 is 13, so I still have the same expression. But the reason that this is helpful is because now I can rewrite I to the 12 using one of these, right? I can either use I squared, I cubed, or I to the fourth. Now it doesn't matter which one you use, but be nice to yourselves. Which one is easier to use? I, for one, not that I don't like negative numbers, but with a negative number, it's easier to make mistakes if you're kind of going fast. So I'm going to use I to the fourth because that's a positive one. So there's not going to be a negative that I have to keep track of. So I'm going to write this as then I to the 13th is going to be I to the fourth. Right? And then I'm going to use my properties of exponents, power to a power. You multiply them. So 4 times 3 is 12 times I. And the reason that I chose I to the fourth is because it's a nice positive 1. So then this just becomes 1 to the fourth, which is 1 times I. So I just get I. So that means that the I to the 13th is equal to I. And that's simplified. So when you're asked to simplify an I to an exponent, these are the ways that you can simplify. You either just get I by itself, you're going to get negative 1, you're going to get negative I, or you're going to get 1. And then they start repeating. Why do they start repeating? Well, if I continue, right, I to the fifth here, notice that then that's going to be I to the fourth times I. I to the fourth is positive 1, so I'm just going to get I. So I'm back at the top. I to the sixth is I to the fourth times I squared. So it's 1 times negative 1, so I get negative 1. So notice that we're starting to repeat. So that's why we kind of just use those 4. And how about I to the 27th power? So same thing, I want to be able to use one of these. Usually these 3, I square, I cube, or I to the fourth. So from here you can go different ways. So you can say this is I to the 26th times I, because that gives you I to the 27th, or you could also go I to the 24th times I cube. Why 24? Well, 24 is divisible by 4, and then I can use the simplicity of I to the fourth equals 1 to simplify that. Either way, we should get the same answer. So I'm gonna do both so that you can see how they work. So I'm gonna do the I to the 24th first. So just as we did before, since 4 divides 24, I'm gonna say this is I to the 24th, I to the fourth, and what times 4 gives you 24? That would be 6. And then times I cubed. So now, because I to the fourth is 1, I'm going to have 1 to the 6th times I cubed, which is just I cubed. And now I can use my table up here. I cubed is negative 1. So I can say this is negative 1. Okay, what about the other way? And so if we go this way, then 26 is not divisible by 4, but it's divisible by 2. So I can use my I squared equals negative 1. So I'm going to say then this is I squared to the 2 times what gives me 26 to the 13. 2 times 13 is 26 times I. So I have I squared is negative 1, so I have negative 1 to the 13 times I. And negative 1 to an odd power is negative 1. So I get negative 1 times I, which is negative I. So notice that we get the exact same answer. And I just realized that I did not put my I here. Negative I. So we get the same answer, right? I cubed from the chart is negative I. I just wrote something else there. Okay, so that's how we simplify powers of I. So now how do we do operations with these? Okay, so adding and subtracting complex numbers. So say I have these 2 complex numbers that I want to add. 3 plus 7i, that's 1 complex number, plus negative 1 minus 2i. This is another complex number. So you might be thinking, well, we don't need the parentheses. And you're right, we don't need the parentheses, but the parentheses are there to indicate that this is 1 complex number, 3 plus 7i, and negative 1 minus 2i is a different complex number. If you don't want the parentheses, let's get rid of them. So it will be 3 plus 7i minus 1 minus 2i. Of course, if we're subtracting, then we have to distribute the negative. And now the way that we add these is kind of like when you have algebraic expressions. The I is kind of like the X or Y or the T, whatever variable you have. That's what makes them like terms. So 3 and minus 1 are like terms. So we can combine the real parts. That will be 3 minus 1. And then 7i and minus 2i are the imaginary parts. So these are like terms as well. So I can say plus 7i minus 2i. So I have the real part and the imaginary parts put together. And so I will say then 3 minus 1 is 2 and 7, right? These are like terms. So the I just indicates they're alike. So I subtract the coefficients. So 7 minus 2 is 5. Okay, so here's another one. So now we are subtracting complex numbers. And again, the parentheses are there to indicate that we have one complex number minus another complex number. Now we can drop the parentheses, but because we are subtracting here, we have to be really careful to distribute that negative. So I'm going to have minus 2 plus I. From the first one, I can just drop the parentheses. Here, I can't just drop the parentheses because I'm subtracting. So minus 5 plus I. And so now we do what we did up here where we combine the real parts. So minus 2 minus 5, those are the real parts of the complex number, plus I plus I. And so my real part is going to be minus 7, and the imaginary part, 1i plus another I, is 2i. And that will be our answer for this one. I do have a third one before we do multiplication. So say I have 2 minus 2 plus I. So notice that here, this is just a real number. But remember what I said earlier, real numbers are complex numbers. So we can write the 2 as 2 plus 0i. And now here I'm subtracting again. So we will have to distribute that. So I'm going to have minus 2 minus I. You don't have to write the zeros, I just want to make it a point that even though that's a real number, you can still write it as a complex number by just saying it's a 0i there. So 2 minus 2, those actually end up canceling, right? I'm going to have, when I combine the real parts, I have 2 minus 2 plus the imaginary parts, that's 0 minus I, so I just get minus I. So the real part goes away, and we're left with just minus I. So this will be the answer. If you want to write it as a complex number, and WebAssign may say write it as a complex number, then it will be 0 minus I. Or if it asks you what's the real part is 0, and then the imaginary part will be negative 1i. I'm going to record another video for multiplication and division of complex numbers.